Our next guest is Adam, and he'll tell us about building agentic workflows in Ruby. Please welcome Adam.
Hello, everyone. I'm really happy to see so many faces today morning. Do you have good fun yesterday evening? Cool, glad to hear that. So, we are living in the AI age. Every day we are hearing new stuff from that space. New news, new patterns, new potential models that can solve our problems, right? So we are living inside some cycles. The announcement, oh, unexpected error happens. So, Anthropic recently announced the new mighty model, Mythos, that might be new breakthrough in that space. Google announced the quantum compression that can change the way how we are running models in local environment. And many LLMs, startups, not startups, but labs living inside the release cycle where release the new models, new capabilities, a very circle. Beside that, we are living in the other re- state when LM's leaders appears in some moment, make some interview, and provide some perspective. And in that perspective, everything is simple, right? But in the reality, it's quite different. And those leaders, organizations, can have some rough time. Even Anthropic has recently the problem with the exposure of the closed source of Cloud Code, right? And where are the typical RP, CRM application that organizations are using daily in their operation time? Where, how they can use these tools in their operation. And if you read some kind of feedback, the most of the most of the elements that and tries finalize after some trial because there is no impact on the business, right? So, welcome on my talk about building agentic workflows, where I will try to provide some pattern how you can, in easy way, apply in some specific case, of course, agentic workflow that may have impact on the business. I narrowed the scope to the B2B relation because inside the B2B you have this some kind of relation between parties. So they are making some communication. They have communication layers where can they interact. So welcome. I'm Adam Okoń. I'm independent consultant working mostly as a tech lead, product developer, building B2B solutions. I'm still using Ruby after 17 years, but also touch a different tech stacks. And as a speaker, I'm co-organizer local Ruby meetups in Tree City, my local arena. And this is my first talk on such a big stage. So thanks, wrocloverb, to encourage me to take this challenge. So today, I would like to talk about the role of the input, why the forms can be bottleneck in the application and in what case, and how we can use Ruby to build such a augmented solution for our forms in the specific case. And I would try to provide some, let's say, hints how it looks like situation after releasing such a stuff on the production. So, are you ready? All right, so let's talk about the input role. Oh, I love it. It's not expected, to be honest. Oh, success. Yes. Okay, so I really tried to put such a complexity on the screen. So I ask my agent to generate as complex form as can, so you can feel this pain, this daily pain of the users. And we are love building such a forms, right? Every framework has the utility to help us to build that because it's a complex task, right? Forms is basic trigger to make the interaction the application, right? It's pretty common, everybody take a look at this, but there is some, let's say, trade-off here. Oh yeah, we have fine success. So theoretically, forms give us a deterministic input. However, there is some, let's say, cost of this for uh, non-technical users. The validation workflow can be really pain. Everyone has such a story that you fill the form and you lose the state. Thanks, React. And inside the front-end ecosystem, you may have multiple solutions for making the forms, and they are still trying to solve this issue every year. So they are, during the life cycle of the product, there are undocumented paths. The product is changing, requirements are changing, so the teams are changing. So this knowledge maybe is not documented. So we may have the dead paths. Moreover, developers pretty don't know about how looks like the real life of the end user. There are some kind of separation, right? And people tend to make some shortcuts. So we are making some optional things. But in the end, you may find that those optional options in the form might not be optional and business wants to have it. But guess what? If people have opportunity to don't feel the things, they will don't feel it. So LMs provides the easy way to analyze the human requirements in the human language, right? So we have very convenient tool to make this kind of activity. But we are not only limited to the analyzing the text, right? We have option to look on the different type formats, right? Like video, audio, PDF files. Moreover, this for that activities, you don't need to train the model. You just make the HTTP call to the provider, which is a very convenient way. And we are able to do that, right? It's nothing new and not rocket science for us. So let me introduce the augmented workflow for the forms when complex form is used only by translating requirements that, for example, account manager received requirements from the clients via email, and this it's translated to the form state, right? So what we can do, we can create two forms, right? So in the asset two-step process, the first step, we just put the requirements as a text from the email and start analyzing phase. And after that, we came to the state that we may have the form that we have previously, but maybe after our audit, we may found that we don't need some things, so it can be simplified, right? But are displaying the suggestion, right? That might not be applied in the moment of when the suggestion appears, or can be applied. Depends on the case, right? Because you may have some compliance rules that need to be manually attached. So in this case, we are providing something that we have as developers, as a mechanism, right? We're making the non-technical people option to make a code review, right? And if you are working in such a regulation market, you have to have such an option to make a control, final control, right? So how we can do this inside the Ruby, using the Ruby tools, right? So in this part, I will try to take a look how we can design this using the monolith approach, how it looks like this inside microservice may look like, because it depends on the case. And I want to also touch the point about what happens when you have a situation with a lot of IO bound operations during the analysis phase. So let's dive in. Before we do something, let's gather first metrics, because this is the something that provide us info if the specific item has sense to build. So most common thing that you can pick is just a time of the operation, right? How long the specific process take. Then get the baseline. So may record such activities during some time, and after you release something, compare, and then you will see the final results. If you burn the time to build that solution, burn the tokens to build that solution, and tokens for the operations. And what is more important thing, use some kind of observability tools to verify what's going on inside this process. And OpenTelemetry is a great tool for that. I will try to present you something. So from my experience, there are two paths. You have typical monolith application where you have some kind of background engine, can be Sidekick or SolidQ. You're using Rails. For LM integration, you may choose the Ruby LM gem, and you are using probably the turbo streams as for real time. And this is one component to deploy. On the other side, if you are working in the site organization that is split it on the teams that have different responsibilities, you may probably be in the situation that you're working inside the microservice world. Let's say depends on the organization, right? And then you have probably a situation that the responsibilities about the LLM communication might be inside one common service, that you don't have governments to make the changes because it's maintained by the different team. And on that level, to communicate between parties, you probably will need some kind of message broker where you send the events. And of course, you have this independent scaling as a benefit of the microservices. So if you want to make this inside the monolith, it's something that we pretty much know. You send the post, the form, you may persist the state. You introduce some kind of intermediate state that you put the data that was sent to make this inside the memory. Because if something went wrong, you can always restart, right, the process. Then, since this is since operational LM requires waiting for the tokens, you probably want to depart this to the background job, right? And then the whole process is taking inside the background job. And this is most important part, because this is not only receiving the tokens, but you want to build this suggestion, right? And during that process, you are not only building the suggestion, but you can use this extra window to do something else, to prepare the state for the other screens for the users. So you may consolidate the different features in that moment. So, as I mentioned, introducing the state that keeps all integration during that phase, the analysis phase, it can be very useful for debugging what went wrong during that process. Moreover, OpenTelemetry helps to investigate if you have found yourself that you have many I/O operation. This is especially inside the microservice world. And the most important part from my experience is that this consolidation window for different service may have the biggest impact on the whole feature, because we are not only speeding up the one view, but we may prepare state for the users on the next phase of the product. So in the result, we have snowball effect, right? That touch base on the different things inside the system. So for the monolith, you probably want to pick the Ruby LM as integration with the LM providers. It's a Rails native support. It can very easily integrate with the Rails active record, the case basic chat functionality, and you can define the agents. It provides the abstraction to define the agents and the tools for the agents. Let's dive into the sample. So you can always ask your agent to build that, but I try to put some kind of example here. So on the left, you can provide, using the Ruby LM API, the tool that extend capabilities of the agent. Also, Ruby LM provides the way how you can build the agent and compose them, compose such a specific, encapsulate the specific domain of purpose, the specific the agent with extra tools. So this is something that for the monolith is ready to go. But if you don't want to use this, you can always use Ruby LLM as just client to LLM provider, because it has very nice API for that. But in this setup that we have, mostly we running the jobs as on the thread-based system, and LLM's goals is a heavy I/O bound operation, and this has some limitation. As you probably heard from the different talks on this conference, there is a different option to do that, and it's a different abstraction that Ruby have built inside this toolkit. So the fibers gives a very nice opportunity to have higher throughput here. So I put some kind of statistics from the great blog post from creator of Ruby LM. Recommend that. It contains a very convenient overview of differences between fibers and threads. So fibers and with support of async gem can give us more performant way to run the LLMs inside the Rails application. The async community have the specific additional adapter for Rails active job. So if we change adapter in our job to async, then we, for heavy I/O bound operation, we can use fibers advantages and scale up operation on LLMs. Regarding microservice architecture, so things are more complicated, depends on the architecture decision in the organization, but what mostly I'm doing is that we have some service probably that utilize the LLMs calls, and we just send the event that requires the analyze phase, and the event in the return to our consumer that we start the analysis phase inside that. So things are here depends on the what architecture you have, but inside the microservice world, it requires some additional complexity like message broker. Depends on what you want to use. The last thing that I want to highlight during my talk is how you want to deal with heavy IO bound workloads. So often during the analysis, the results of LLM, you may find that if you add one thing and it works, there is always people who tend to add something more here, and you are in the situation when you have many IO operation that may last some time. It has negative impact on the whole user experience here. So maybe there is some solution for that inside Ruby toolbox. So Async Gem provides very nice API that you may have concurrent IO operation, and this gem provides very nice barrier abstraction that schedules the IO tasks, and by default, without new parent nil, it schedules the task until the system is not overloaded. So this simple abstraction has very powerful internals that the task will be scheduled till system is not overloaded in 80%. And after that, there is unbound. The unbound task will be canceled by barrier. So this very simple API covers very edge cases for you. And here, I just disabled this management because also async provides option to manually managing the concurrency using semaphore. So you can define how many slots do you want to use. This is very handy on the microservice world, where you want to make some throttling when you're asking some services to not call at once multiple requests and make some local DDoS. So you may find that this solution solves that problem, and we may have much faster IO operation. And this is one of my favorite features from Async Gem. So during this conference, I think it's many talks that highlights that in the community, we are starting to distinguish the heavy CPU operation and heavy IO operation. Even during this week, the new Puma version has a new thread pool, which is fiber pool. So we can see that the community is starting expanding to use the new patterns to handling the differently concurrent IO operation and CPU. But there is a question: do we need this form at all, right? We can use direct communication with email, for example. So, because now in the race we have the action, we have a component that can receive the emails directly, right? So we can send emails directly to the race application and run this process without manual operation from the user, right? So we not only decreasing the time when the whole form is created, because we want to probably send the suggestion with, via email to the account manager, and here we reduce the time when the message is coming to the organization, right? So this is not only reducing the time in the app, but outside the app. But in this case, we are open to receive notification from different sources, right? The webhooks and other pipelines. So this is what actually OpenClaw and other agents doing right now, right? They have integration to many systems, right? So maybe we are coming to the situation that our system will be have adapters to the majority streams and just send us the things that we need to just approve to move on. So let's talk about the production case study. I made something like similar in last half a year, and the result was remarkable. So we have such a situation that we have not complete data sets. We have a very complex form operation that takes some time to fill in. And there was other problem that there was created some supported features for that process, but they weren't used by the user because user has some habits and it is very hard to change the user habits. So when we apply this workflow, reduce dramatically the time of operation, but we also increase adoption of those tools because we prepare the state for them. So we move burden from them. And the positive effect was also the human relation because the user was very grateful for change their lives in the daily operation. So the key takeaways from my side. So this augmented form that you introduce the new step where you provide opportunity to paste the requirements in the human text and then analyze. It opens the new window that you can consolidate the different services and of course may reduce the time of the operation. Moreover, before you do that, define your KPI, track if this makes sense, and Ruby is ready for that kind of solution, right? Because async is providing new way how we can handle the heavy I/O workflows. So, thank you for your time.
Thank you. Any questions?
Hi. Just a question about the thing with the I/O performance.
Yeah.
In actual use, like what is were you able to measure the difference between using fibers, using async,
Yeah.
and the traditional solution?
Yeah, so at the beginning, I made just sequential calls, right? So we have a case when the whole workflow took, for example, above 50 seconds, right? When we used async, we cut down this to the around 15, 20 seconds, right? So there was huge difference on that. And I have feeling that, come on, give me more, what I can load more, right? Because it's easy, right? We have very easy abstraction that gave you a lot of capabilities to do complex workflow in easy way. And this kind of thing, it's very easy to extend.
Yeah, thanks for the presentation. And my question is, why did you decide to go with a mostly AI-related approach instead of just probably optimizing the UI? Because as we saw in one of the previous lections, so there was a lection about the events, and there was a cool UI which has drawn with these complicated forms separated into steps, and each page contains only, instead of like containing 20 fields, it contains only 2, 3 fields, probably 5 of them, and that just makes the AI much easier. So why did you decide to move on with the AI-related approach?
Well,
Thanks.
I can only provide, let's say, my opinion, but from my side, the best UI is no UI.
Hey, I'm wondering why you are using like AI on the backend side, because right nowadays you can use in a browser, so you could really embed some information that could be really used for AI on the web, even like Chrome probably will have a
Yeah.
embedded in the future. Right now you can use a web LLM. Really, it's a little bit hard because it's a couple megs to really download, but it can really do everything what you have on the backend. Just fill like the gap with knowledge, and that would fill the form automatically, really. And yeah, like most of those things which you have on backend, you could pre-fill even without AI.
Okay, so I will give you a short answer. The security department probably will ban this solution. Really? Yeah. Okay. If you are working in the regulated market, probably yes. Yeah, but anyway,
Okay, there's one more question. Oh. Need to figure out how to reach you.
Thank you. So I have two questions.
Yeah.
Forms usually give the user, the structure. They know what are the options they can pick from. With AI, how do you, challenge that?
Yeah, that's great questions. Thanks. So this happens during this analysis phase. So this is like a local ETL pipeline that you have some data and then you make some transformation that you propagate via WebSockets.
Knowledgeable.
No.
In your case, the users know their options.
No.
No.
Sorry. The form always provides the way that you can fill in manually. So they
Yes.
have the options.
Exactly. That's why I like
Okay.
the form, not the paper. For
Yeah.
instance.
Yeah. So, and actually, before the meeting, I checked X today, and there was a message about that Anthropic just canceled subscription, the whole company. So beware and make a backup solution always, right? Because you can always be cut off.
Okay, so the second question is like, while the user is filling in the form, the complex forms,
Yeah.
sometimes it's just a nested method to get to some, if I select this, then my selection is already scoped with the previous selection and so on and so forth. The question is like, how do you walk the user on this path of filling in the form with AI so he is knowledgeable whether the AI is understanding him right?
Yeah, this is also a good question. I don't have, let's say, good preview of the slides here, so I haven't remember all things, but probably I haven't mentioned that you make the audit of the form and maybe this nested thing, you don't need this. You simplify the path for the user, right? Or maybe you remove this nested option, right? And make it flat.
Or maybe you can offer the user the preview of the actual understanding of the LLM like we have in our terminals and so on and so forth. Or there's also alternative to that approach to kind of cross-check with the data that you trust. So whatever AI is understanding, you cross-check with some data, like for instance, the actual physical locations to find out the address that the user is giving and the AI is understanding is actually the existing address or things like that. Yeah, thank you very much.
Yeah, so my final, let's say, takeaway is that try async in your workflows. Use the telemetry to view what happens in your application, and you may find that this abstraction may bring you additional benefits. Thank you.
All right. Thank you very much, Adam.